So I just want to finish off the serverless stuff with you today, which means really talking about or finishing off our discussion on Cognito. And there's a lab this week, which is the one down on the bottom left there. That lab just steps you through the Cognito sample application that I started talking through the last day. And that Cognito lab is going to be useful to you for the assignment because if you checked this website within the last 24 hours, really, I've put up the specification for the first assignment and I want to talk through that with you today as well. I don't see this lecture now going the full 2 hours, so uh, that's fine. So back to our discussion on this Cognito service. Just go right back to the beginning. Just to set the scene, so Cognito is this service that essentially looks after user authentication and authorization. And the service provides two kind of concepts, really. One is called user pools, the other is called, where am I? Sorry, where did I mention user pools? Am I on the wrong slides? I am, sorry. Let's fast forward. Yeah, Cognito. So anything to do with user authentication, stroke authorization, rather than you programming it yourself, you leverage this service to do some of the low level stuff for you. And it talks about two uh, concepts, user pools and identity pools. We tend to associate Cognito identity pools with the whole IAM part of AWS, whereas user pools are linked to the more web kind of login authentication type scenario, and that's what we are interested in. And to illustrate these Cognito pools, I started looking at this sample application, which kind of reflects typically the way we structure any client-facing application built on the AWS platform, any serverless client-facing application that requires some sort of user authentication aspect to it. We tend to break it up into two parts. So that's why we've got two web APIs illustrated here, and the top API in this diagram that looks after all of the authentication stuff we said the last day, and the bottom web API is the entry point for all of the application's kind of core functionality. So anything to do with sign up, sign in, sign out, all of that is directed at the top API in this diagram. And behind that particular API, which we kind of refer to as the auth API or authentication API, there are a whole bunch of lambdas. There are a whole bunch of lambdas, and all of the lambdas that are here are taking care of talking to the Cognito service. Uh, and within the Cognito service, there will be a user pool that we have created specifically for this application. The nature of the communication between these lambdas and the Cognito service is very, by nature, I mean the kind of programming model. It's very similar to the programming model that we had with DynamoDB in that we create command uh, instances and we send those commands to the Cognito service. Yeah. So as I said, the programming model across a range of AWS services, at least in the TypeScript world anyway, the programming model is very similar for good reason. And so authentication on the at the HTTP protocol level, we talk a lot about tokens, and the most common type of token that we use is a JWT token. Um, um, and so when the user has registered, when they then come along to log in, eventually what they receive back is a JWT token, a JSON Web Token, and that token then is used uh, when they want to actually send requests to any of the core functionality down here. Some of the functionality down here may not require the user to be authenticated, and some will. Um, for for those parts of the application that do require authentication, the token is included with the request. And then this particular web API down here, it will use another Lambda function, which again we have to implement. And we refer to this Lambda function as the authorizer. And basically its role is to communicate with Cognito, asking it essentially, is this token valid? In other words, was it generated by you? And was it generated by you for a particular user in a particular user pool? And it'll either come back with a yay or nay, in fact. And then this Lambda somehow needs to tell the web API that this is a good token or a bad token. And the way I've implemented that, and to be honest, this is a solution that I kind of found on the web. The way the Lambda tells this web API whether it's good or bad is by providing an IAM policy. And essentially then the web API, this API gateway here, uses that policy to determine whether the request that originated from the user is allowed to pass forward to the backend or not. So it's a simple policy that either allows or denies the forwarding of the request. The request, if it is forwarded on, essentially what the request that's forwarded on to the Lambda is the exact same request that was issued here, right? So any headers, HTTP headers that were part of this request, those headers are going to be passed on here. Now, of course, it's not HTTP here. We know that what API Gateway does is it wraps or it creates an event object and passes that event object to whichever Lambda needs to be invoked. But that event object contains within it the full HTTP request. And so, for example, the actual JWT token that was included here, that now is actually available to the Lambda over here, should it need to use it. It's available to it within the event object. So the last day, we looked at some of the lambdas up here. We looked at the lambda that deals with user registration. We looked at the lambda that deals with confirmation of user registration, because the actual user pool that we created within our CDK stack indicated that we wanted to allow the user to self-register, which included allowing the user to confirm their registration. And the particular mechanism that Cognito uses to enable a user to confirm their registration is Cognito actually sends an email to the user with a particular code, and then we use that code in a confirmation request that goes through this web API again. So we talked our way through that the last day. Where I finished up the last day was eventually now the user can actually submit a login request to this web API, and eventually, having gone through this process here, what is returned back to in response to that login request is a JWT token. And for no particular reason, I decided to include the token as a cookie, although I actually also included it in the body of the response, but you wouldn't typically do that. You either return it, well, you return the token in a HTTP response header. And the particular response header that I'm using is the cookie header. Okay, so that's kind of where we finished off the last day. And so we were using Postman to test all of this. And so where I am now is in my Postman. In my Postman, I want to send a request to the what I call the app API. Let's go back to slides again. Just for clarity, we refer to this as the auth API, and this is the application or app API. So my functionality consists of just two skeleton lambdas. One lambda I've decided is going to be a protected lambda. So the user needs to include their JWT token before they can trigger that lambda. The other lambda is a public lambda, no token required. And the URL associated with those two lambdas, again, was just trivial. There's a slash protected URL and a slash public URL. So going back to Postman, and they're both HTTP GET requests, again, just for simplicity. So here I want to send a GET request to the app URL slash protected. Oh, yeah. And I need to include my token. And so here we can see in the request headers, if I pull this down a little bit, if it allows me. Well, okay, you can see the cookies HTTP request header, and I've assigned it just a variable that I've declared in my collection, my Cognito collection, which is back here. Here's the token variable, and it's actually assigned the cookie, the the JWT token that was returned back to me in a cookie form. By cookie form, I mean cookies, as you know, are essentially kind of key value pairs. The key in this case, and again, it was just arbitrarily chosen by me. The key is called token, and the value then is everything after the equals sign. But all cookies have that structure. It's key equals value. Okay. Right. So that's back to here. Uh, that's the only cookie. There could be other cookies in general. So if I wanted to send more cookies, then what I would do here is I would go colon, the key of the next cookie equals its value, colon, sorry, it's not colon, colon, the key of the next cookie equals value, colon, key value, etc., etc. It doesn't arise in this case though. I'm only including one cookie. And I did say the last day that at least that's what I found in Postman. I have to include this header as well, the host header, which Postman actually sets for you anyway. You don't have to know what exact value do I need to assign to that, the host header. Postman will do that. Okay, so that's my request. And if I send it, assuming my cookie hasn't expired now because I created the cookie a little while ago. Yeah. Okay, so that's the response I'm getting back. And if I look at the actual lambda that I've tried to trigger, it's this lambda here. And the response is that message there, and uh, yeah, that's what I got in the response in Postman. So that seems to have worked. Just as a matter of interest, what I'm also doing in this Lambda is I'm trying to decode the token. Okay. Uh, Come back to the mechanics of how I do that, and then I'm console logging the actual uh, decoded token. Yeah. So what does that console log actually look like? Well, if we go over to CloudWatch and do the usual thing, there's two log streams here now. If you think for a second, how come there are two log streams? Because there was only one Lambda, we think anyway, only one Lambda was triggered. Well, the reason there are two log groups, sorry, is because there were actually two Lambdas triggered. And if we go back to our diagram, um, this Lambda was triggered. So one of the log groups relates to it, and the protected Lambda over here was triggered, and the other log group belongs to it. So that's why there are two. But in terms of the protected Lambda, which is this one here, and it's only one log stream because we've only triggered it once. And I think let's see, it's probably this one. Yeah. So this is actually the contents of the token when it's decoded. So for example, see here, I can find out the the username of the user that made the request. I can find out the email address of the user that issued the request. Of course, these are all coming from this token was generated by Cognito, and it knows those details because it has it in the user pool. So there is useful information in the token if you decode it within your backend functionality. That's just by the way. Okay. So all that's left really is this lambda here, and rather than what I actually kind of decided to do was just describe what that lambda does. I mean, you have the actual code, but so we looked at all this. This is another, I was talking about this, and this is just a website which allows you to decode JWT tokens. Okay, so I just pasted in a token that was generated by my application, and what I got on the right is I didn't check the detail now, but this is almost identical to what I console logged in my Lambda, in my protected Lambda. Uh, oh yeah, maybe if I did make this point the last day, but how do you tell the app API that a particular Lambda is protected or not, i.e., it requires the token to be authenticated. And the way you do it is, and I did talk about this last day, is from a CDK infrastructure point of view, you need to create an instance of a request authorizer. And part of the configuration of that request authorizer is to point it to the Lambda function that is implementing the authorization, right? Which in my case looks like it's this Lambda here. And you also tell us where in the request that comes in from the client, where is the actual token located? And this is telling us that it's located in the cookie request header. So you create this request authorizer construct, and then when you're integrating your backend functionality using, in our case, Lambda integration. So this Lambda integration here, this is where I'm adding a method to my app API. I'm using Lambda integration, which is the only type of integration we've looked at. But in this integration, you can see here I'm including a reference to the request authorizer construct just above it there. Whereas down here, this is the public endpoint in my app, and I'm not actually telling it anything about the request authorizer. So that this is really how we make a particular endpoint public or not requiring protection. This is how we make one protected or requiring authentication, sorry. But again, I talked through that the last day. The actual authorizer, this is kind of the steps that it performs. First of all, it actually takes the HTTP request cookie header, like the value that's assigned to the HTTP request cookie header. Not too sure now whether I should be jumping around too much, but if I go back to here, right, the actual request, which is this part here, as I was saying, in general, there could be many cookies included in the request, and the cookies are, as I said, they're separated by colon, and it's within each between two colons, there is a key equals value. Yeah. But this entire thing here is just a string. That's how it's sent. It's sent as just one big long string. Now, what in my case, what the request authorizer does is it takes this big long string and splits it up, parses it, and puts the information into a map data structure, which is obviously much easier to process from a programming point of view, where the keys in the map are the keys of the cookies and the values are the values of the cookies. Okay. So it does that just to kind of create a more programmable representation of the actual cookie header content. So it now has a map data structure. A map is just an object, set of key value pairs. Then it looks through that map for a key called token, because that's what I decided to use in my case. So now it has the actual the value associated with this key is obviously the JWT token that was created by Cognito. If it doesn't find it, it returns an IAM policy that says deny access to the backend functionality. If there is a token key within the map, that means we do have a JWT token potentially, but we need to verify it. The verification process really involves communicating with the Cognito service. So that's just a Cognito call. And the Cognito service, it actually performs the verification. And what it returns back, if it is a valid JWT token, it actually returns a data structure representation, a decoded representation of that token, which I showed you there on the screen a while ago when I console logged it. Otherwise, I think it returns either undefined or null. I didn't look at the detail actually of the uh, what the cognito method returns, but let's say it returns undefined, which means essentially it's an invalid token. And so then my authorizer lambda just checks to see did the verification was it successful or not, i.e. did it return a valid object or not when I ask Cognito to do the verification. If it did, then I'm returning an IAM policy that allows the web API to pass the request on to the backend protected Lambda, otherwise generate an IAM policy that denies it. Yeah, so that's what it does. I'm kind of loath to look at the code, but there is one thing in it that's kind of useful to us. So this is the actual authorizer. Yeah. And it's doing what I mentioned in the slide there. The very first thing it does, it calls this is just a utility function. So I'm gonna leave that file open. Calls a utility function called parse cookies. And if we look at that's where we take the cookie header string and break it up, which is what's going on here. Okay. You can look through the code yourselves really, but suffice to say that what this method returns is a map data structure. Again, a map is just a JavaScript object with a set of key value pairs. One of the keys, hopefully, is the key called token. But that's what it returns, I think. It returns the actual map data structure. The authorizer then says, well, okay, did it return? Sorry, what does it do? Hopefully it returned something. Maybe if there were no cookies at all in the request, then clearly there's no JWT token. So when you look at the code for this again, it'll return undefined or null, I think, if it doesn't find anything. Hopefully there is something. If there isn't, then generate my IAM policy that denies access to the backend functionality. Otherwise, what it's doing down here then is where it's talking to the Cognito service. So where does it call Cognito? Well, right there, really. Okay. Is that right? Sorry, verified token. Well, this is actually a local function. Let's go down to it. Verified token. And, there's a bit of fancy stuff going on here, but essentially, okay, it's making a HTTP request. It's making a HTTP request to this URL here, but this is a URL that the Cognito service exposes specifically for the purpose of accepting requests to verify a JWT token that it has issued. So it's a bit hard coded, but there you go. So the net effect anyway of this verify token is that it either returns a decoded version of the token, which is a kind of an object, or it returns undefined, I think. Okay, and so if I go back to my authorizer, let's see if verify token. Oh yeah, like it's my authorizer is using this, which I've said now a couple of times. This is either going to be pointing at a decoded version of my token, or it's going to be equal to the value undefined. And I'm just checking to see essentially down here, like, is it a true or is it truty or falsy? And that determines whether I return, whether I set allow or deny as within this IAM policy that's been generated here. Okay, you can just scan through that code, but look, it just works, and anytime you need to use it, you can just copy and paste it, and it works for you. You don't have to understand the detail of it. It's worthwhile just scanning over it, though. The If I go back to the protected Lambda, okay, I'm essentially doing the same inside here in that I am, let's see, what am I doing? Yeah, I am, oh yeah, that parsed cookies utility method, what you pass it is the event object, which the event object is a representation of the HTTP request. If I go back to my, sorry, go back to here. So HTTP request comes in, and this uh, API gateway calls this Lambda. And as always, what the API gateway does is it takes the HTTP request, generates an event object, wraps the HTTP request inside that event object, and calls the Lambda. Okay, so it's that event object that I'm passing down to my parse cookies method. Yeah, there. Okay, that's the event. That's what it, and then parse cookies does what it does. We now have our cookie map. And again, even though this code that I'm showing you now is the code of my protected Lambda, the Lambda that Maria has some functionality that the user is interested in triggering. Again, I'm just checking to see, well, was there actually any cookies included in the request? Return some sort of an error. I could actually show you that if I went back to here and if I go to my get protected and if I disable this and if I send that request, uh, oh, unauthorized. Well, that message now is actually coming from, that error message is coming from the result of this Lambda not finding any cookies, it telling API gateway deny access to the backend Lambda. And so API gateway sends a response back. So it never actually gets to my protected Lambda at all. But, there could be hackers in there that try and trigger my protected Lambda in various ways. And so that's it's still valid within my protected Lambda to have this kind of checking going on. Okay, so I can't actually show you this response message, but that's okay. I get the token verified. I call the verify token method within my protected Lambda. I now have the actual decoded token and I console log it. And I showed you what the console log produced. Um, so again, within my protected Lambda, you can actually get at the token because it contains potentially useful information that maybe your protected Lambda can use as part of its processing, whatever processing it's doing. Right. Um, are there any questions? This week's lab, back to there maybe. This week's lab is all about setting up that Cognito sample application that I've been talking through this morning and the last week as well. Yeah. So it's quite long, I suppose, quite a long lab, but just work your way through it. There are no exercises in it. Work your way through it because the code, the completed project having worked through this lab will be of use to you in the assignment, which brings us on to that.
Dear mate, can I
Yes.
ask you a question?
Mm-hmm.
So I was just looking through the lab that you were mentioning there, and I'm seeing on multiple pages that you're saying to add files into the lambdas folder, but I saw within your code demo that you were using a folder called Lambda, and within our, I guess, sample folder, we have Lambda as well. So if people were creating a new folder called Lambdas to put the code into, it wouldn't have been following the, I guess, the code demo that you were showing us
I
there.
gotcha. Yeah, it's quite possible that I've made that mistake. That's a mistake on my part. So, Lambda folder, it's meant to be. I don't care what you call it. It's meant to be the same folder, but it's a good spot.
No worries, thank you.
Great. I'll try. Maybe I'll just quickly look over the lab after this lecture just to try and correct that so that people don't fall into that trap if they haven't attended this lecture or listened to it back again. Right. The specification is predictable enough. I essentially want you to create your own RESTful web API. It'll be quite small scale now, though, really, because there's only going to be one. I'm suggesting that you probably only need one table. You may need a second table, depending on what grade you're aiming for. But at the very highest level, this is what the objective is. Just demonstrate your understanding of creating a serverless REST API using CDK framework. The context, by context, I mean whatever the nature of the functionality of your app API is completely up to you, right? Which really means what type of data you're storing in the database table is completely up to you. There is only one constraint, though, which is that the table has to have a composite primary key. So uh, that's like our movie cast table, because that was storing the fact that movies had many cast members. So it's that kind of one-to-many type relationship. You want to be storing something uh, of a one-to-many type relationship in your database table. You can decide what context to use. Don't use movie cast though. Okay, there's a deadline. It's worth 20%. Again, this is what you'll be submitting is just text file containing your GitHub URL and a YouTube demo of your application. Um, sorry, a text file containing just those two URLs. It's really, really, really important that you keep a Git log right throughout your time working on this. So I expect to see Git commits starting from now forward, okay? And do lots of commits, have meaningful commit messages. I don't care if a commit, like what I won't be doing is rolling back one of your commits and see, does this commit, does this version of your application work at this stage in its development process? I will not be doing that. So in other words, you can have a commit where there's some part of the application still broken. It's not still working. Okay, which wouldn't be a typical thing in industry now. You wouldn't commit on uh, faulty code as such, but I'm fine with that. So the more commits, the better. And again, try to have meaningful commit messages. The commit message should always kind of state um, why what were you working on up to this, between this commit and the previous commit? Don't talk about what files were changing, but what was the nature of what were you trying to achieve? Yeah. Okay. So if I go down, so I've got a kind of a detailed specification here of your RESTful web API, but if we just go down to the database part of the specification, and I've sort of already mentioned this, right? Just make sure that your database table, and I'm saying that you'll have a minimum of one. You may need a second table depending on some other aspects of this specification that I'll talk about in a moment. But if it is only one table, it must have a composite primary key, and that table represents the context, I'm calling it, for your RESTful web API. So come up with your own context and just make sure that the data table that's storing information about that particular context has a composite primary key. Also, just make sure that at least one attribute within each item of that table is a numeric attribute, and have some text attributes as well. And try and, well, not try, but make sure you have at least one text attribute that's whose content is, a sentence or maybe a couple of sentences. And I'll explain why we need that later on. So it's kind of a description type attribute. Yeah. But other than that, it's pretty straightforward. It's just a single table. Yeah. So going back to here then, in terms of the API itself, this is kind of the app API now. You need to have a support for a post request that adds items to your table, a parameterized get request. By parameterized, in the case if we were using movie cast as our context, then a parameterized get would be get a particular cast member for a particular movie. I have to specify the table's partition key and sort key. Is that what I'm trying to get at here? So I'm just trying to remind myself. Oh, sorry, no. Sorry. A parameterized get in this case would be where I'm requesting all of the items that have the same partition key. So in the case of the movie cast, I want all of the cast members for movie 1, 2, 3, 4. 1, 2, 3, 4 being the parameter of that particular get request. Sorry there, I just confused ye and myself now at the beginning of that, but that's okay. So you need one of those and only one. There's no point in giving me 5 or 6 of them because you won't get extra marks for that. One parameterized get request. Here I'm saying have support for an extended version of that parameterized get request, where the extension is a query string, which kind of performs filtering on the collection that's returned by the parameterized get. So in the lab, for example, we had a get request to return all the cast members of a particular movie, and then we had a query string where we said the actor's name had to begin with Bob. Okay, so we were narrowing down the collection that we were interested in. It was a form of filtering. So I'll just have one example of that. Have support for a put request. So you need to be able to allow requests that allow the user to update an item in your table. Another get request, but this get request is about getting the backend to not just get a particular item from the table, but in addition, it should translate all of the text strings within the item, translate them into a particular language as requested by the user in the request that the API received. So, for example, kind of a generic example of might be this. So I want to get of whatever things would be the context now in my case, the partition key. So if we just stick with the movie cast, so it would be get slash movies slash a movie ID slash the start key, I think was actor name in our case. So this would be actor name. So I'm getting a particular item now, one item from the table. And then I have a slash translate. And then I have a query string. And the query string is specifying what language I want the text strings within the item to be translated to. In this case, it looks like I want them translated into French. Now, there is an AWS service that does the translations for you called Amazon Translate, and I mentioned that further down in the spec. But from a web API perspective, this is the path name of the endpoint that you need to support. So it's a slightly different endpoint to the parameterized get one up here, to this one, in that it has this slash translate part added on to the end of it. So that means it's going to go to a different Lambda than the Lambda that's supporting the standard parameterized request. And also it has a query string, and the query string is exactly of this format slash our language equals. Where am I? Sorry, down here. Language equals value, where the value is a language code. And the language codes are actually dictated by the AWS Translate service, which I mentioned further down in the spec. Now, in addition, if you want to, obviously there's extra marks going for it. What I'm saying here is that ideally your web API should not carry out the same translations multiple times. So if we stick with the movie cast example, so if my web API receives a request to carry out a translation of all of the text fields in the item whose movie ID is 1234 and the actor name is Joe Bloggs. If my API receives the exact same request subsequently, it's better that it doesn't go back to the AWS Translate service and get it to do that again. What we might do is actually store translations in our database. So that means now that whenever my web API gets a request to do a translation, it first of all checks to see, have I done this translation already? Is it stored in my database? And if it is, then just return it from there rather than communicating with the AWS Translate service, because that would take more time and potentially it would cost more if we were doing this up in the kind of millions of requests type scale. So you need to work out though, how do will I store the translations in the same table that I'm storing, that's my kind of main table, or will I have a separate table for it? I'm not too concerned whether you pick one or the other. I'm not looking for kind of design decisions. I just want a solution. So I don't care what approach you take. Use the same table or have a different table. You then have to decide what is the primary key of that alternative table. But that's the requirement that I'm adding on to this translate feature. DynamoDB table side of it, I've kind of talked about that. So that's why I said at least here. There's at least one table. It depends on whether you're going to use a second table for storing your translations. And again, to repeat myself, I don't care which approach you use. I won't be evaluating one or the other. I just want a solution that works. Moving on, we'd like our web API to have authentication and authorization. And really what I'm allowing you to do here is you can use all of the code from the Cognito lab. You can lift that and drop it into your assignment solution, and then just plug it into your particular app API. From an authentication point of view, I'm saying that post and put requests can only be carried out by people, by users that have authenticated first. In other words, the request to the post and put must include a JWT token, a valid JWT token, otherwise it should not be passed through to the backend. And if you're interested in extra marks, there's a piece here where I'm saying that only the person that added an item to your table should be allowed to update that item. Okay. So again, you need to come up with a solution for how you satisfy that constraint. So whoever adds an item to your table, only that person should be allowed to update that item. Then I have a bit on Amazon Translate, and I'm giving you a link here to a video. And if you watch that video, I think everybody should be able to implement the translation feature. It sounds difficult, but it's not actually. So you need to watch that video and follow along, and then try and just copy and paste stuff into your project to get it working. Grading spectrum, if you're aiming for 40 to 50, then just make sure that you've got support for your kind of basic GET requests. There doesn't even have to be support for the query string part of it and the post request. So just have both of those working, and have seeding for your database, but we know how to do seeding. I've shown you how to do that, so that shouldn't be too difficult. In the 50 to 65 bracket, functionality, all of your gets should be working. That's both the standard get, the extended get with the query string, but you don't have to have the translation stuff working. You do have to have the post and put working, and also that constraint on the put, the fact that only the person that posted the item should be allowed to update the item. You need to have a solution for that in order to get into this 50 to 65 grade band. 65 to, what is it, 85? Is where you're doing the translation, and you're also persisting the translations to avoid the repeating of the actual translation process itself. And then if you're aiming for something higher than that, 85 plus, then I'm just mentioning two things here. Pick one of them, either multi-stack app or Lambda layers, and implement one or the other in your overall solution. But obviously you have to read up on, well, what is multi-stack app all about? And you'll get lots of examples really. Similarly for probably slightly less for Lambda layers, but maybe just read a little bit about both of them, and if you may prefer one over the other, or one might be easier than the other, or you might get a good example of one straight away that works for you, and then just implement it in your overall solution. Obviously take an incremental approach to all of this. Maybe just get the simple get working first, then try and get the post working, then the extended get, then the push with no constraint, then the put with the constraint. Take an incremental approach, which you would do anyway, and do your commits as you're working your way through it. That's the specification. Do you have any questions? No. Okay, have a read over it, and if you need to, you can contact me on Slack. So, just in terms of the context now, you know, more than one person might have the same context, but if that arises, then obviously I will keep a close eye to make sure that there isn't anything other than that. It's just a coincidence, so might be best just to pick a context and keep it to yourself so that there isn't overlapping going on. But it may happen anyway, but I will obviously have to keep an eye on it if I see a number of projects with the same context. That's slightly unusual. Okay, there are no questions it seems, so that's all I really want to cover with you today. And we've kind of finished serverless, although we'll still be doing lots of Lambda stuff after the midterm break. So enjoy the midterm break. You're going to be busy, I know, doing this and other stuff, but I'll talk to you again in 2 weeks' time. Okay, bye for now.